You saw in the investigation of our sine and cosine functions here, what our sine and cosine graphs look like. And they go forever both directions. And that's really part of the reason we have the idea of a negative angle. Negative angles going clockwise around our coordinate plane, because that helps to define our function for negative values. Make sure on your sheet, didn't know if we would have time to go through it during class or not today, but make sure you have on your investigation sheet your x-axis labeled, your y-axis labeled, and that you can see some of these key features. So looking at our graph for sine of x, sine starts at the origin, a full period is 2 pi, and then each quarter point, so if you split your whole period up into four chunks, each quarter point we go to the highest, midline, lowest, midline. So each quarter point we're either at our highest point, our midline, or at the lowest. The sine again starts at the origin, to the top, middle, bottom, middle. Cosine, same idea, the period is 2 pi, but instead of starting at the origin, we start at 1. We start at the highest value. So start at the highest, middle, lowest, middle, highest. Really, if you look at the graphs, sine and cosine are really just transformations. They're translations of each other. If we translated our graph for cosine to the right pi over 2, then we'd have the same as our sine graph. So anyway, just wanted to point out those key things. Make sure you have these points labeled on your investigation sheet so you can look back. Now also in your investigation, you found out that when we add that slider here for A, and then move what our slider is, we move that A value around, your amplitude changes. If your A value gets larger, that amplitude increases. And if we have a negative A value, that's a reflection too, same as our transformations before. In this second little section, we graphed some more transformations, sine of 2x, cosine of 4x, all of these. And all of these, hopefully you notice that for each one, the period changes. And this number inside either does a horizontal stretch or horizontal compression, and that affects what the period is. So in general, the number in front of the x, 2 pi divided by that number in front of the x, tells us that period. Now all of that is going to be very important. Our A value here determining our amplitude, and the number in front of the x helping determine the period. And keep that in mind when we go into our first example today, where we are going to graph some sine and cosine functions. And I'll do example 1a here. Let's graph y equals 10 times the sine of 4 theta. Now, right now, all of our graphs, all of our functions that we are going to graph will have a midline on the x-axis. We'll have a midline at y equals 0, just time permitting. You'll do some translations of sine and cosine functions next year in pre-calc. So that's kind of a good thing to start off with, I guess, that our midline is going to be at y equals 0. And looking at our equation, hopefully you can identify the amplitude pretty quickly. If you think of it as your vertical stretch, Your number in front here is our amplitude. So our amplitude is 10. Now remember, amplitude tells us how far up and down we go from our midline. And then to find the period, we have to take 2 pi divided by the number in front of our angle, divided by 4 here. And 2 pi over 4 simplifies down to pi over 2. All right, let's start graphing with the information that we have. So I'm going to draw my x and my y axis in here. And it's sine, so I know sine is going to start at the origin. And our amplitude is 10, so we'll go up to 10, and we'll go down to negative 10. And I also know the whole period is pi over 2. So I'm going to go out a little ways. And I'll have this represent pi over 2. Now, looking back at your investigation, remember me saying that here's the whole period. Each quarter point tells us something important about our graph, whether it's where we're at the midline, the highest, or the lowest. So we need to make sure that we graph those quarter points as well. So take that whole period, cut it in half, and cut each half in half. And it's also good to label these. I will expect you to have each of these marks labeled as well. And really the easiest way to label each one of these markings, they're all quarter points of pi over 2. So take pi over 2, that period, times 1/4. And you'll get 1 pi over 8. So this first mark is 1 pi over 8. The second mark is 2 pi over 8. Which you can also call pi over 4. This one is 3 pi over 8. And then 4 pi over 8 is the pi over 2. Okay, that's probably the easiest way to label each of your markings. Then sine again, we start at our midline. Each quarter point is the highest, middle, lowest, middle. And then we can draw in our graph. And these are kind of awkward to draw in. Try your best to get that sinusoidal shape, that curve. Something like that.